All right, well, here we are again. Welcome back to Tech Math. We're going to be looking here at section 1.7 as we move into some other operations. Now, before I jump into this section of material, one thing that I do want to spend just a second to discuss is early on in this class, there's a lot of content that we're going through that's probably not the most riveting. As we go further into the course, there's going to be a lot more practical content dealing with a whole range of different topics. So units of measurement, scales, things of that nature. And so for the most part, you may be like going through these sections and wondering like, what did I sign up for? I understand that. A lot of this stuff is really important information early on in the course, and we really need to have just a firm grasp of the things that will continue to come up as they come up. Otherwise, if we move on to the other stuff, we're probably just going to get left in the dust with some of the more important kind of, I don't want to call it theory, but more essential skills as we move forward. So if you've read through the notes that I've been typing out, you'll notice that in the previous few sections, I've really written quite a bit of content. The notes were pretty long, and so what I wanted to do is simplify them down a little bit. These notes that you see here in front of us, it's kind of like the first section where I don't write nearly as much or as many notes. And so that's intentional. I'm doing that intentionally because my goal ultimately is to hopefully get you to start reading the textbook. It is one of the better textbooks that I've seen. I've seen a lot of textbooks in mathematics classes over my entire time here, my career, and I will say that I think this one is probably one of the best textbooks that I've seen. It's very good with its examples. It has great interactivity to it. So when you get to the end of a section, if you want to work through similar problems, they have a little button that you can literally just click the button and it'll show you the answer. So you can kind of work on some of those skills just like we do here in the class, because many of the examples that I'm actually going through are questions that are right at the back of each section. So that being said, I did want to just make sure that you were aware of that. But today what we're going to be doing is talking about section 1.7, which is addition and subtraction of fractions. So if you take a quick look here, you'll notice that we have a couple of things going on. Now, this is more like like the theory of it in a sense, that if we have something with the same denominator, okay, the same bottom part, denominator is the bottom. If we have something with the same denominator, effectively what we do is we just combine the numerators together. So we have an a plus b divided by whatever that single c was. Okay, so it's actually kind of funny, but adding and subtracting fractions is actually more complicated than multiplication and division. And we're going to talk about multiplication and division the next time, but yeah, this concept or this idea of adding and subtracting is actually trickier because in most cases what we have to do is we have to find what's called common denominators or the same denominator so we can combine them together like we see here. So the textbook does have a process. You can follow that if you would like. They go through kind of a more kind of handwritten approach. Mine is a little bit more mental. You can still write it out. But I'm going to just show you my example, and if you're curious about seeing kind of a different methodology, then you can go into the textbook if you'd like as well. So let's take a look at this example here real quick. Okay, I have to find the lowest common denominator. So with the lowest common denominator, that means that these numbers here, we need to manipulate the fractions so that the bottom numbers are all the same. And so the way that we can start to do that, or manipulate them, is just by taking the smallest values. So in this case, I'm going to take the 3, and all you have to do is just start multiplying it. So we'll start with 3, we get 6, we get 9, 12, 15, 18, 21, 24, and, you know, you can take it out. I don't know how far you want to take it, but, you know, a few numbers. Then we can go to the next smallest, or the next, I guess, largest. 6, 12, 18, 24, 30, 36. And then lastly, we go with the 8, which is the next, the largest one, 8, 16, 24, 32, 40. And then you compare. So I've got 3 different lists here, and we do a comparison between them. And what we're trying to do is we're trying to find the smallest number that appears in every single list. So from the looks of it, it looks like the answer is going to be a 24. Okay? That number that we just found, that's the smallest number that appears in every single list, is going to be our common denominator. So, we're not quite done yet. The next question we need to ask ourselves is, within each of those lists that we see, how far was that number that we found, that 24? So for the 3s, it was 1, 2, 3, 4, 5, 6, 7, 8, right? And that actually makes sense if you think about it, because 3 times 8 is 24. So it's 8 numbers in. And so what we're going to do is, however far along in that list we go, we're going to take the multiplication, so it would be 8. We'd multiply that number by whatever is up top in that same, it's this one here. We'd multiply that number 8 by the number up in the very, very top of that fraction where the 3 comes from, okay? So in this case, we would, you can read the notes here, 1 times 8 divided by 24, which is the common denominator, is the same thing as 8 over 24. So all we're doing is we're just converting 1/3 into 8/24, which, if you can see, those are actually the same thing. They are exactly the same thing. It's just that they have, it's almost like you're scaling it to be a little bit bigger. That's it. Like the numbers in the top, in the numerator and the denominator, you're just scaling them to make them a little bit bigger. And the reason why we do that is, again, just going back to the original point, we want to make sure that all the numbers in the denominator are the same so we can add them together correctly. Now let's take a look at the 6. The 6 list. 1, 2, 3, 4. Okay? We know that 6 times 4 is 24. So that means that on the 6, the 1/6, I'm going to multiply the top and the bottom by 4. So I'll get the 24 on the bottom, and I'm going to get a 4 on the top. So you get 4 over 24. It's also listed right here. And for the 8, it's a 3. So we multiply the top by a 3, and we get 3/24. Now that we have all of these fractions into its appropriate or converted form, where they have the same denominator, all we have to do at this point is then combine them all together. So I've got the 8 over 24, which was the very first one, the 4 over 24, and the 3 over 24. And now that I've got everything together, I've got all the denominators exactly the same, I can go ahead and take the 8, the 4, and the 3, combine them together into a single fraction up in the top, and then just add. So the 24 stays around, doesn't change, and the 15, that's the number I get from adding the 8, the 4, and the 3. So, are we done? We're close. We're almost there. This goes back to what we did the last time, where we found the prime factorization of the top and the bottom, and then we canceled things out just to reduce it or simplify it down into its most simple form. So what you'll notice is that 15, the prime factorization is really just going to be 5 times 3. And then down below, the 24, you can break it out. If you want, again, go back to the previous lesson and you can see how this all works. But again, like I said, usually when I have even numbers, I like just kind of dividing by 2, just kind of working my way down. So 24 is divisible by 2, so I can pull a 2 out, and then I'll have 2 times 12. 12 is divisible by 2, it's just 6 times 2, so I'd have 2, 2, 6, and then 6 is divisible by 2, which would just be 2 times 3. So that's how you get that kind of breakdown right there. And what you notice is that the 3's can cancel, And so what I'm left with is just going to be 5 divided by 2 times 2 times 2, which is just 8. So in other words, the equivalency, 15/24, which is what we got, is the same thing as 5/8. Okay? And again, I just mentioned here how I reduced it. When we deal with mixed numbers, the process is quite literally exactly the same. The only difference is we just add the numbers that are sitting out in front, and then we have to find common denominators for all the little fractions that live inside of those mixed numbers, and then combine them together. So I'm going to go through some examples here, so hopefully you can kind of see how this all works out. I would be writing this stuff down if I were you. I don't know what it is, but like I know, like personally from my perspective, I mean, I teach face-to-face classes too, but online even more so. I think it's important for you as you're kind of watching these videos and stuff that you're taking the time and kind of writing down some notes on your own, especially the examples that I'm about to go through. It's really important to write all that stuff down because of it just does something kind of mentally. I don't know what that is, but just from my experience, like I know that I can't really understand or retain information well if I don't write it down in some capacity. And I think maybe that's just because it's if you're like a kinesthetic learner, kinesthetic means like you have to move. I'm very fidgety. If you ever see me in a class where I'm learning something, not teaching, but I'm learning, I'm always like fidgeting with stuff. And that's totally normal, actually. There's some research behind that's a distinct style of learning that people have. They just have to be active and engaged in some physical capacity. And so, so make sure you're taking notes. It'd be really, really good, I think, for you just in terms of retaining information. All right, let's go over to the whiteboard, and we can go ahead and get started working on this, or Blackboard, I guess. All right, so let's go ahead and take a look at this question here. We've got question 8, which is going to be 1/2 plus 3/8. Okay, 1/2 plus 3/8. So here's what we need to do. Okay, first we need to convert our numbers or our lists into the appropriate form. Okay, so if you notice 2, 4, 6, 8. Oops, messed that up. Okay. And then 8, of course, is just its own. So it looks like right here, that is going to be the number that we are going to have as our common denominator. Now, so the first one, the 1/2, how far or how many numbers out did we go? 1, 2, 3, 4. So that right there is going to be the number that I multiply the top by, and the bottom is going to be 8. So as a result, we're going to get 4/8 plus 3/8. You can probably notice right off the bat that this, because it's a 4, or I should say because it's a 1/2, pretty much it's just going to be whatever the number is that you find, however far out you have to go. Pretty much that's it. So I won't complicate it. So this is going to be 7/8. Okay. Let me move this up here. All right. Question number 10. So on this next one, we've got 5/6 plus 1/18. Whoops. My handwriting is pretty bad today. Hopefully this can get resolved. All right, so same kind of process. Let's go ahead and take a look at the 6. And we'll do 6, 12, 18. Notice that that's the number right here. 18 already lives there, so you don't have to worry about this, the 18. And how far out did we go? 1, 2, 3. Okay, so this, because it's a 5/6, it's a little different. Up above we had a 1. But now that 5 means we just have to multiply by the 3. So 5 times 3, we count out 1, 2, 3. That's where that 3 comes from. And the bottom is going to be 18. And over here, we've got 1 over 18. This one doesn't change because it's just, that was already the common denominator. So that's good. Okay, so now we can multiply the 5 times the 3. We get 15 divided by 18 plus 1 over 18. So this is going to be 16 over 18. And right off the bat, you can kind of see how this actually can be reduced. And remember, we can reduce it specifically here because both the numerator and denominator are actually even numbers. So if that's the case, I can just cut them in half. So I can cut the 16 in half and I can cut the 18 in half because the 2's are effectively going to cancel each other out when I factor it out. So here I'll have an 8, and over here I'll have a 9. And that's going to be my final answer right there. Let me write this one right there. There we go. All right. Moving on. The next question, this one's a little bit more complicated. There's some methods that you can use to figure these out, but I sat down and I looked at this question and I'm like, man, this is so stupid. I'll just be honest, some questions are dumb, okay? But I wanted to show you kind of a dumb one to show you, and when I say dumb, I mean it seems very complicated. There are some methods that you can use to figure out what these common denominators will be, okay? So on this one, I've got giant numbers, 14 and 15, and then just a random 6 thrown in. So off the bat, I'll just be honest, you can sit and start writing lists out, but you're going to get, it's going to be a long time before you get to an appropriate number, okay? So there's another method you can use to figure out common denominators, okay? For the most part, we've been looking at least common denominators, but they don't necessarily have to be the least common, okay? They can just be common. You can get it or change it to the least common when you get to the very end and do the same process we did here by then reducing it down. So that's actually the approach that I'm going to take on this question. I will write it out the other way that I showed, or my suggested way, just so you can see how insane it is. So if I start with 6's, 6, 12, 18, 24, 30, 36, where are we at? 42, 48, 54, 60. If you look and I start working on the 14s, computer's slowing down a little bit here. 42, come on, 56, and 70, 84, right? You can see there's nothing here. 42, yeah, okay, there's a 42 there, I suppose. Let's go ahead and do the 15s now. The 15s is where this is all going to fall apart, and you're going to see this really quickly. 15, 30, 45, right? I'm not usually a big advocate of this, but in situations like this, frankly, I would just go into, there's some software online you can find. Well, I shouldn't say, it's not software. There's like programs that you can go to. There's a website that's really, really helpful for a lot of different problems. It's called wolframalpha.com. Wolframalpha.com. It's a really good one. There are some just online tools also to help with finding common denominators. But you can kind of see what's happening here, right? No, that's not 70, it's 75. What am I doing? My computer just slowed down very, very quickly, and I'm not sure why. There we go. Okay, so here we are. We've got all this stuff, and there's nothing really looking common here. The common denominator, it's kind of crazy, actually. The common denominator is going to be 210. And you're probably like, dude, how are you seriously expecting me to multiply 6s all the way out until I get to 210? And the answer is no. That's because that's kind of insane, right? But this is like a question that shows up common. It's a common question, and it's something that you can do. But there's certain ways that you can go about solving them to make them a little bit easier. The marking it all out and writing out each of these lists is just one way to do it. Another way to do it, and you can start kind of here, baseline, is to take the two biggest numbers. Okay, so this is a different suggestion that I didn't have in the notes. Take the two biggest numbers and multiply them and see what you get. Turns out 14 times 15 is, in fact, that right there. It's 210. So that right there is going to be the common denominator. Okay. In fact, 15 times 14 is kind of nice because that would be like a pretty large number, but it's also going to be the smallest one that could possibly work if 14 and 15, if there's some kind of like factor that's there. So in any case, so let's go ahead and figure that out. How many numbers did you have to multiply out to get to 210 with 15? Well, that would be 14. Okay. So what I'm going to do is just in this blue, I'm just going to mark down next to it 14. Okay. For this one, this is 15. This one's not bad. I mean, it's just the opposite. Okay, and then the last one, the 6, we don't really know that one. So we got to figure that out. So to do that, all you have to do is just divide 210 by 6 to get the number that it would require to multiply. So in this case, it's 35. So you have to multiply 6 by 35 to get there. That means that if you were writing this whole thing out, you'd have 35 specific different entries until you got up to 210, which is just bonkers. Like, I don't expect you to have to do that. So use a tool. It's fine. I don't have any problem with you doing that. I figure like when you're on the job, you're not going to be trying to do all of like something like this in your head. You're probably just going to punch it into a device. So go ahead and do that. That's fine. All right. So that being said, since 1 is the top here, let's go ahead and multiply. So I've got 1/14. So the 14s is going to be the 15 over 210. Then I've got the 14 over 210. Forgot the 1 there. And then we've got the, in this case, 35 over 210. And so as a result, this all sums together. I've got 15 plus 14 is 29. 29 plus 35, whatever that is. So it looks like it's going to be a 64 over 210. This is going to write. Come on. This program has just slowed down so much, so I'm working on it. Just give me a second. 64 over 210. 64 over 210. Okay, so now that I've got that, notice really quick, we can reduce this down even further. 64 over 210. This is the same thing. If I cut it in half, it's the same thing as a 32, right? And this will be a 105. And remember, the last thing we do when we check divisibility, you can see if either of these sum up to 6, or I should say like a multiple of 3. 5 plus 1 is, that adds up to 6, which is 3. A factor of 3, I should say. So that means that 105 is divisible by 3, but unfortunately 32 is not divisible by 3. So this is as reduced as we possibly can get. Can't go any further than that. So it's also our final answer. Okay. All right. Let's go ahead and move on to the next question here. Same kind of idea. So on this next one, we've got, this is question number 20. We've got 3/16 plus 1/8 plus 1/3 plus 1/4. All right. And now, same kind of process. We can work it all out. You know, again, I mentioned the trick of just writing all these out, but when you have 4, it just becomes really kind of a pain. So you can take combinations of them. This is like another trick that I mentioned. So the last one I showed you that if you multiplied the two biggest numbers together, you get 210, right? In this instance, you can multiply the two biggest numbers together just to see what you would get, okay? And one of the things that I would suggest doing is you can do 16 times 8, but you can also check the other ones too. So 16 times 3, for example. Okay, this is going to be 48. 16 times 4 is equal to 64. Okay. And then we can check to see if 3 goes into any of these numbers. 3 doesn't go into that one, but 3 does go into 48, which is cool. 4 goes into 48. We knew 3 did because 16 times 3, duh, that makes sense. 48 and 4. 48 divided by 4 is 12, so that works. 8 goes into 48. 8 times 6 is 48. So I think 48 is actually going to be the number here. I know some of it is trial and error. You can figure that out, but in practice, it kind of works out to be that way, okay? All right, so 48 is a common denominator, so that means that in order for us to get this, we're going to have 3 times 3 here. Over 48. That's going to be for the 16. Then for the 1/8, we would multiply the 8 by 6, 8 times 6 to get the 48. So this would be 6 times 1, all over 48. I'm lagging so bad right now. Hopefully this doesn't have an impact on playback quality, but we will see. The 3 is going to be the 16. 16 times 1 over 48. And then the last one, 1/4. That is going to be, what did I say, 12? I think it's 12 over 48. So 12/48 is the same as 1/4. 16/48 is the same as 1/3. And that's how it goes. We've got 3 times 3 is 9 over 48. It's one of those things that can be really distracting, not only for me, but for everybody else. Because if I'm distracted, then trying to work through this stuff is much more complicated. And then lastly, we've got the 12 over 48. Okay? All right, so now all we have to do is add all those things up. We have 9 plus 6 plus 16 plus 12. You can do 16 plus 12 is 28, plus another 9 is going to be 37 plus 6. And that should be, hang on a second. See, now I'm looking at this, 3 over 48. 3. Yep, okay. Yeah, sorry, I'm just, I'm in my head too much right now. So I actually have my my calculator out. Let's go ahead and punch this in, see what we get. 9 plus 6 plus 16 plus 12 is 43. So we get 43 over 48. Alrighty. And I think that is pretty much it. I don't think we can reduce that any further. 4 plus 3 is 7, so that 3 doesn't go into that. Yeah, I think that's it. And they're both, one's odd, one's even, so we can't cut it in half. All right, yeah, that's pretty much it for that question. Let me do one more, and then... Actually, I got a couple more. Well, yeah, I didn't do one with a mixed number. So, oh, by the way, subtraction. I'll do one of these. So subtraction is a really good one. It's the same process, except we're just subtracting instead of adding. So if I do this, minus 13 over 32, minus 1/8. Okay. What we're going to have here is 9 minus 13 minus 1, but we have different denominators. So right off the bat, you can start working 8, 16, 32, 24. Ha, forgot that one. It only works when you multiply correctly. 24, 32. There we go. And it looks like 32 shows up there. 16 times 2 is also 32. So 16, 32, right? And then 32 is the common number here. So that right there is going to show up and be our common denominator. So the number that we had to count out to, 1, 2, is 9 times 2, all over 32. 13 is, well, this is going to be the same thing, 13 over 32. And then in this case, 1, 2, 3, 4, 4 over there, and then over 32. So this is the same thing as 18 over 32. Minus 13 over 32. Minus 4 over 32. And that right there, we just do the subtraction. So 18 minus 13, that's going to be a 5. 5 minus 4 is going to be 1. And there you have it. That's our final answer. Very cool. All right. How do we do it with the common issue of like mixed numbers, right? So if I'm going in here and I've got mixed numbers that I'm dealing with. So say, for example, question 43. Suppose I've got 3 and 9/16 plus 4 and 7/12 plus 3 and 1/6. Okay. So the thing is, with mixed numbers, the process is pretty much identical to what we've been doing up to this point. All we have to do on this is combine together the coefficients, so the 3, the 4, and the 3. We'll combine those together, 3, 4, 3, 3, 7, 10. And then we have to just worry about the stuff that's back here in the fractions, okay? So 16, 12, and 6, you can start multiplying those out. So 6, 12, 18. Oh my gosh, I'm getting horrible lag on this. I'm sorry, everyone. 6, 12, 18, 24. I got to fix this issue. 30, 36, 42, and 48. Okay. Oh, and of course I'm behind the My numbers are behind. 48. Okay, it goes 1, 2, 3, 4, 5, 6, 7, 8. It's 8 out. So in other words, this is going to be the same thing for the 6. So we've gone, I'll write it here. We've gone 8 out total for there. For the 12, 24, 36, 48. 48 is going to be the number, so we're 4 out there. And then on this one, we've got 16, 32. Whoops. See, man, this is screwing me up big time. $16, 32, and 48 here. Okay, and that goes 3 out. All right, so we've got 10 is the whole number. Now we just deal with the 9/16, the 7/12, and the 1/6. So 9/16 would be 9 times 3 all over 48. We add that to 7 times 4 over 38. We add that to 1/6. See, this is not the 1/6. This is going to be the, oh my gosh, this is like becoming completely unusable here. Eight times 1 all over 48. This should be 48. Okay. And now we just add all these together. So 9 and 9 is 18, 27 over 48. Plus 7 times 4. 7 times 14, 21, 28. All over 48. And then I add that to 8 over 48. And so again, if you have your handy calculator right next to you, you can go ahead and punch all those values in, which is 27 plus 28 plus 8, which is equal to 63. Over 48. Now, here's the deal. Because this is an improper fraction, we have to change that from an improper fraction into a mixed number, okay? And so the trick here is that 48 goes into, remember, it's the Price is Right trick here. 48 goes into 63 pretty much one time with a remainder of, it looks like 15, I think. So I've got 48 plus 15 over 63, or over 63, geez, what am I doing? 48. Okay. 48, come on. So this is the same thing as 1 and 15 over 48. But it looks like the fraction here can actually be reduced even further. So 3 goes into 15 and 3 goes into 48. So now I can just divide those fractions by the 3, and I'm going to get a 5 here. And then down below, 48 divided by 3 is going to be 16. So that's our reduced form. So this is the thing that we're adding to the end of that. And as a result, we're going to get an 11 times 3 over 16. Or 11 3/16. That would be our final answer. Okay. Oh, 5/16. What am I doing? See, this computer thing is just screwing me off right now. It's so bad. So this should be a 5. All right, there we go. Final answer. We're done. I'm going to work on fixing this computer issue. Hopefully this video is completely usable. If not, then I'll have to re-record it. But in any case, I hope you have a great day. I'm going to get to work on this here real quick. And if you have any questions, feel free to let me know.